Hello everyone. So today I'm going to talk about my favorite subjects back in high school, geography. A lot of things that geography talks about, such as space, maps, population, earth, and many more. But today I'm going to pick a topic about Earth. Earth is the planet where we live on right now. It's one of the 8 planets in our solar system. And it is the only known place in the universe that supports life. Back then, in the 17th century, Galileo Galilei observed and discovered Jupiter. It had moons of its own. And that Venus went through phases like the moon. Observation continued, ideas caught up, and finally it was established that Earth was planet among many others. The name of Earth is at least 1,000 years old, and it's Germanic word, which simply translates to the ground. It is not known who came up with, but it's the only planet that wasn't named after a Greek Roman god. The name of our planet came from the Anglo-Saxon word Erde and the Germanic word Erde. They both mean soil or ground. The Old English version of these words became Earthe or Eartha, which later transformed into Earth. Many other languages use some variation or naming of their own, such Arade. It's in Dutch, African, Flamania, and then Tere or Terre, Tere, Jordan, Bumi, and many more. Earth can be referred to as Earthling, Earthers, Terrans, or Gaians. Earth is an oblate spheroid. This means it's spheral in shape, but not perfectly round. It has a slightly greater radius at the equator. The imaginary line running horizontally around the middle of the planet. In addition to bulging in the middle, Earth poles are slightly flattened. The geoid describes the model shape of Earth, and it used to calculate precise surface location. Earth has one natural satellite. It's the Moon. Earth is the only planet in the solar system to have one moon. Venus and Mercury do not have any moons. For example, while Jupiter and Saturn each have more than 12 moons. Now, aren't you guys curious how Earth is formed? Well, the Earth is believed to have formed around 4.5 billion years ago. The duration for this formation has been estimated to have lasted about 10 to 20 million years ago. The theory states that a solar nebula partitions a volume out the molecular cloud, gravitational collapse, which begins to spin and flatten a circumstellar disk. The planets grow out of that disk through gravity pulling swirling dust and gas. Slowly, the Earth's atmosphere and ocean were formed by volcanic activity and outgassing. It is believed that water vapor condensed into ocean, being augmented by water and ice from asteroids, protoplanets, and comets. The atmospheric greenhouse kept the ocean from freezing when the newly formed sun had only 70% of the current luminosity. When the Earth's magnetic field was established, it helped to prevent the atmosphere from being stripped away by the solar wind. A crust from when the molten outer layer of Earth cooled from a solid. There are 2 models who propose that the landmass steadily grew to present-day forms, or more likely that it grew rapidly early in Earth's history, followed by a long steady continental area. The continuous loss of heat from Earth's interior helped continents form through plate tectonics. Through periods of hundreds of millions of years, the supercontinents have assembled and then broke apart. About 750 million years ago, the earliest known supercontinent Rodinia began to break apart. The continents later rejoined and combined again to form Pannotia about 600 to 540 million years ago. This happened again, and the supercontinent of Pangaea formed, but also broke apart about 180 million years ago. There are patterns that suggest that Ice Age began about 40 million years ago and intensified during the Pleistocene around 3 million years ago. Many high-latitude regions have undergone repeated cycles of glaciation and thaw, repeating about every 40,000 to 100,000 years. It is believed that the last continental glaciation ended 10,000 years ago. Now, after talking about how Earth is formed, let's talk about the atmosphere. Atmosphere is the layer to protect Earth from the meteor and other strange things from space. The atmosphere by volume is about 78% of nitrogen and 21% of oxygen, 1% of argon, and the rest an assortment of trace gases. Water vapor is also present, almost all of it below a height about 8 to 15 kilometers. This part of the atmosphere is the warmest of the bottom, creating convection in the air, then in turn currents of rising air. They carry water, forming clouds, which in turn is why we have weather. The ozone layer is situated at height of 25 kilometers on average. This is molecule of oxygen that absorb every solar ultraviolet light. These types of light is dangerous to biological molecules, thus the ozone layer is critical for our protection and survival. Here I'm going to explain 6 major layers of the atmosphere. The first is troposphere, the lowest starting at ground level and extending upward to about 10 kilometers. Most of the weather occurs here and most clouds are present. The second atmosphere is stratosphere. It extends from the top to the troposphere about 50 kilometers above the ground. This is where the ozone layer is present. Unlike the troposphere, it gets warmer upwards. This means a lack of turbulence favorable to commercial jet plane rides. And then the third atmosphere is mesosphere. It extends upwards to height of about 85 kilometers above the planet. Most of the meteors burn up in the mesosphere, and unlike the stratosphere, the temperature drops again, with the top temperature reaching about minus 90 degrees Celsius. The air here is far too thin to breathe, and the pressure is well below 1% of the pressure at sea level. The fourth atmosphere is thermosphere, a layer with very rare air and high energy X-rays and radiation from the sun being present but absorbed by the thermosphere. This raises the temperature considerably, and most satellites orbit the Earth in this layer. The auroras, northern and southern lights occur in the thermosphere. The top of thermosphere varies between 500 to 1,000 kilometers above the ground. The fifth atmosphere is exosphere, considered the final frontier of Earth's gaseous envelope. The air here is extremely thin and leaks into space. The top once again varies from 100,000 to 190,000 kilometers above the surface of Earth. The later value is about halfway to the moon. The final atmosphere, or the sixth atmosphere, is ionosphere. It is not distinct layer as the previous ones. It is rather a series of regions and part of the mesosphere and the thermosphere, where high energy radiation from the sun has knocked electrons loose from their parent atoms and molecules. The electrically charged atom and molecules are called I am enjoying the region with some special properties. That is all, you guys. Thank you so much for watching and listening this week's presentation. I hope you guys liked it. I hope you guys enjoyed this video because this is the hardest video that I ever made. So yeah, hope you have a great day. Bye.